Okay, we have the rational exponents and radical functions review. And first up, we have cube roots, two cube root questions. And you're asked the cubed root of anything. What that's saying is, what number do you cube to get what's underneath? Okay, so what number do you cube to get 729? Okay, a number you multiply by itself 3 times. 9 times 9 is 81. 81 times 9 is 729. So that's why this one is a 9. Uh, 343 is going to be, let's see, well, maybe we don't have, oh wait, let me plug in my adapter. Hold on, wait. Okay, sorry about that. Yeah, I didn't want to lose power in the middle of the recording. So 343. 7 times 7 is 49. Times another 7 is 63. Carry the 6. 28 plus 6 is 34. So 343 is 7 cubed. So the cube root of 343 is 7. Next up, they have 27 to the negative 1/3 divided by 27 to the negative 4/3. Now, there's a few things we could do with this, but the main thing is that we just need to subtract the exponents. Since the bases are the same, we could take advantage of that. And if you have a negative 1/3 and you add on 4/3, then that's going to be 3/3. So that'll be 27 to the first power. So this one is 27. Okay, now let's deal with these square roots. We have the root of 80. Not a perfect square. That's asking what number do you square to get 80? And there's no integer answer. So there's not a perfect square answer for that. What we can do is find perfect squares that go into 80. The first thing you think of is 4, but there's actually a bigger one. Let's just do what you would think. Let's do 4 times 20. And so we'd have to do the square root of 4 times the square root of 20. Square root of 4 is a perfect square. That's 2. And then just that 20 has a perfect square that goes into it. So 4 also goes into 20. And so we break that down to be the root of 4 times the root of 5. And so we get another 2 out there with the 2 that was already out there. So the answer is 4 root 5. We could have done it all in one step if we knew that 16 went into 80. So we get 4 root 5 for the root of 80. Now let's deal with the root of 245. Okay. A perfect square that would go into 245. Well, not 25. No. Well, how many times 5 go into 245? Let's do that. So we get 4 times, and then we get a 45. That's a 9. So 245 is 49 times 5. There we go. So it's the root of 49 times the root of 5 is equal to 7 root 5. Okay, so 4 root 5, take away 7 root 5, treat it like x's. 4x minus 7x is minus 3x. So we get minus 3 root 5. Okay. Next up we have a cube root, but inside we have multiple parts. And so we have negative 125 and x cubed. And we think about them separately. If we're trying to take the cubed root of that product, we can take the cube root of each part. So the cubed root of negative 125 and the cubed root of x cubed. These two quickly just cancel out. You just get x. And here we're asked the question, what number do you cube to get a negative 125? That's a negative 5. So the answer then would be a negative 5x. Okay, and then we have a 4 over y, 4y to the 2.7 over y to the 1.35. The 4 doesn't play a role. It stays there as a constant. And so we're going to leave the 4 there and subtract the exponents like we had done before. So we have y to the 2.7 take away 1.35. I believe that's half of 1.3. Half of 2.7 is 1.35. So we get 4y to the 1.35. It's positive, so it's in the numerator. Okay, and then finally the last one we have a y cubed and then a fifth root, and then minus a 7 and then a fifth root. Okay, let's deal with the fifth root. We have the fifth root of 32 and the fifth root of x to the fourth. There's nothing we could do with the fifth root of x to the fourth. It's going to stay like that. But the fifth root of 32 is asking what number do we multiply by itself 5 times, or by make 5 copies of and multiply them all together to get 32, and that's a 2. And so I write the 2, but it doesn't show up. All right. So anyway, so what we get is it's not cooperating. Okay. Jeez. So yeah. So we get 2 times the fifth root of x to the fourth for that part. So we have y cubed with a 2 out there with it times the fifth root of x to the fourth. And then for this part, we have the fifth root of x to the fourth times the fifth root of y to the 15th. And this is going to stay again. This one's not, though. It's like taking y to the 15th and raising it to the 1 over 5. The fifth root is the reciprocal exponent, so 1/5. And so when you raise a power and raise another power, you can just multiply these together, and so that's y cubed. So we're going to have minus the 7 that's there, the y cubed that's there, and then the fifth root of x to the fourth. And we combine them. This is like having the variable. If you have 2y cubed of something and you subtract 7y cubed of the same thing, you end up with negative 5y cubed of that same thing. Okay, so those are our answers to the first part. Just looking at radicals, cube roots, fifth roots, square roots, and different exponent powers, exponent rules, and involving those. Okay, great. Let's do a pause before we jump to the next one. Okay, so we have number 2, asks for you to take the function x squared minus 4, take the function negative x cubed, and subtract them. So when you subtract them, you'll just get x squared minus 4 minus a negative x cubed, which is just a plus x cubed. So x cubed plus x squared minus 4 in standard form, decreasing exponent. Then they want you to take g of x and multiply by itself. They want you to take negative x cubed and multiply by negative x cubed. Think about this as negative 1 times x cubed times negative 1 times x cubed. So the negative 1 and the negative 1 multiply to give you 1, and x cubed times x cubed, you add those exponents to get x to the 6th. Okay, great. And then we have a composite function, g of f of x. And what that has you doing is taking f of x and replacing, substituting it in, replace the x that's in g. So g of f of x means g of x squared minus 4 means that you replace the x that's in g with this entire function, x squared minus 4. So when I want to say negative x cubed, I can't. I put the whole function x squared minus 4, and that's what needs to be cubed. Now be careful of the order of operations here. We need to take x squared minus 4 and cube it. So we multiply it out, unfortunately. And there's another one. And so what that gives you is x to the 4th minus 8x squared, combining those two middle terms, plus a 16. And then that gets multiplied by another x squared minus 4. And so we do the distributing, and we get x to the 6th minus 4x to the 4th minus 8x to the 4th plus 32x squared. Where are we at? Plus 16x squared. I'm going to run out of room. Minus 64. Okay. So that's x to the 6th minus 12 x to the 4 plus 48x squared minus 64. That's what you get when you cube out x squared minus 4. And we want the opposite of that. So then when we go to write our answer, we'll just change all the signs. We'll have a negative x to the 6th, a positive 12x to the 4th, a negative 48x squared, and a positive 64. Okay, great. This is a totally separate concept here, but now we're going to look at inverse functions. verify that f and g are inverse functions of each other. It's not totally separate, but here's the idea. For you to have these guys be inverse functions, you need the following to be true, that when you do the composite f of g of x, you just get x out. And then flip it around, g of f of x, you just get x out. That means they're inverses. So, we just need to show that's true. If I take f of g of x, boy, I don't know what's wrong with this computer. I wrote the f a long time ago. I'll write it again. It's not cooperating. Okay. Jeez. F of g of x. So that is, when I want to say 3, wow, the delay is killing me. What is going on? Why is there a delay? Ay. All right, I have to pause it. Ay. Come on with the delay. All right, well, I think the computer's about to crash on me. Unfortunately. Jeez. What? Come on, wake up. Okay. Oh. Keep the current screen. And pause the recording. Jeez. Come on, man. Don't crash on. Okay, I think it might be good now. I think it might be okay now. Let's see. When I want to say 3, no, it's not. X minus 4. Okay. I can't take it anymore. I gotta go to some other software. This is too much. Geez, let's try Word out. I don't know if that's gonna be better. Hopefully it will. I can't even open it. What is going on with this computer? Ay. Sorry. I have to pause again. Okay, so we'll try a different software here. So we are on PowerPoint now. Let's see if this works. So we have 3x minus 4. That's what f of x is. We need to replace the x with the entire function g. X plus 4 over 3. And if we work this out, the 3's cancel. You'll have x plus 4, and then minus 4. The 4's cancel, and you have x. So the first part is right. The second check, g of f of x, is when you want to say x plus 4 over 3, you put the entire function f in there. And then you don't need the parentheses. It's 3x minus 4 plus the 4. The 4's cancel. all that's over 3. You're left with 3x over 3, and the 3's cancel. So yes, you have x. So they are inverses. We verified that. And then finally, we'll do it for the other set, where we have f of x being 2x to the 5th. So when we want to say to x to the 5th, we say the entire function g gets plugged in. And when you raise it to the 5th and it's already underneath the 5th root, they cancel out. And so you just get what's underneath, and then the 2's cancel out. So you get x. They just want us to verify, and that's what we're doing. We're just verifying that the two functions are inverses of each other. Here comes the delay again. Jeez. G of f of x is, when you want to say the 5th root of x over 2, you put the entire function f in there. And so the 2's cancel, and you're looking at the 5th root of x to the 5th, which is x. And so these guys are inverses of each other. We just verified that. Okay, I'm going to cut this in half. So I feel like this recording is about to die on me. Let me go ahead and stop it here, and we will record the rest on another video. Really? Won't even let me? I can't even stop it. 1 second. I'm sorry. Wow. I'm going to use a different program for the other part to the video. Wow. Come on already. Uh-oh. I hope I didn't lose it. Okay. Stop.